let us see. This is chapter number 6, which is data types revisited. So we have seen about the primitive data types, char, int and float, but there are other options which are available regarding this char, int and float depending upon the requirement. So not only the primary or primitive data type, along with this you can have a character, say unsigned char, signed char. You can have an integer which is called as short int and long int. So what this short, long, unsigned, signed means. So let us discuss in this chapter what this character, integer and float have to offer you. Integers, long and short. Integer, we are talking about integer in C. So we need to understand that it is compiler dependent. For example, if it is a 16-bit compiler like the Turbo C or Turbo C++, the range of integer is negative and positive. These are the numbers. Why? Because integers take negative as well as positive number. So if you take 16, 2 to the power 16 to be exact, you get, if you combine these two, you get this number. Since if this is a number line, then you take 3, 2, 7, 6, 7. Here this side you have minus 3, 2, 7, 6, 8. So this is the range. Similarly for 32-bit compiler, it is 2 to the power 32 and just divide it into two parts, left, right. And I'll tell you why this number is 1 greater than this one. It's in the negative, but it is 1 greater. We'll talk about that later in the discussion. So whenever we are dealing with, say, 16-bit, this microprocessor like this Intel, so this C program, when it generates machine language code, this is targeted toward working on a 16-bit microprocessor. As we said, 8086, 8088. But if you are making program in VC++, so the 32-bit compiler, this generates a machine code which is targeted towards 32-bit compiler like the Intel Pentium. So this means that a 16-bit will work on 32-bit, 32-bit on 64-bit, but the backward compatibility is not there. Means if you have made a 32-bit program, it's highly unlikely that it is going to run on 16-bit. Just remember that out of this 2, or you can say 2 for 16-bit, 4 for the 32-bit, this is the byte which this integer take in the memory. So out of this 2 or 4 bytes, this is used to store an integer. The highest bit is used to store the sign of the integer. Highest bit is for the sign. So if you have a negative number, that means the highest bit will be 1. And if the number is positive, the higher bit will be 0. Highest bit will be 0. So there are various offerings like short and long. And the thing is that sometimes you don't want the integer is there, but you don't want that long that integer. You have the numbers. You know that in your program the numbers are going to come less. But there are possibility that you are not satisfied with integer. You want more than integer. Then you have to go for a long. So short, usually in our discussion when we are dealing with the Turbo C and Turbo C++ compiler, this short takes 2 bytes and long takes 4 bytes. So short, and this totally depends on the operating system and hardware also. So let us give a least limit for that. Shorts are at least 2 bytes big, means short cannot be less than 2 bytes. Long are at least 4 byte big. That means if a long integer is being defined or declared, it is going to take at least 4 bytes in the memory. Shorts can never be bigger than integers, and integers can never be bigger than long. So if we have short, then we have integer, then we have long. So this is how it increases, the size increases. So this is the summarization. If you are dealing with 16-bit compiler, the short will be 2 byte, integer will be 2 byte, but the long will be 4 byte. If you are dealing with 32-bit compiler, short will be 2 byte, integer will be 4 byte, and long will be 4 byte. So how to declare them? Just put a long in front of that int I. Int I you have been doing a lot up till now. just put a long here. So this long int ABC or long int I means now this long integer is taking a bigger size. So it is going to, for this example, if you take this, it is going to this I in memory, wherever it is stored. If I is stored, say I has some value 3. So it is going to be stored, and this is going to take 4 bytes. How much memory? 4 bytes. But please understand, if the size is higher, the program will be bit slower. Because if you see, this is 4 bytes. So 4 byte means 4 into 8 bit, that is 32 bit. So the range goes from 2 to the power 32. This is the range. Means you take half of this on the negative side, half of this on the right side. This is how it goes. So if there are such things like things as longs, you should have something which require shorter than what is required. So this integer that needs less space in memory, which is short. So this is just to speed up, increase your execution time. So how to declare a short integer? Just put a short in front of int. And one more thing, short int and short, they are similar. So even if you write short int or short, they are equivalent. Even if you write long int or long, they are equivalent. So you don't need to put an int here. You can do this shorthand. And most of the C programmer, they prefer this kind of declaration in their program. Now, sometimes we may have certain situation where the constant is small enough to be an integer, but still we want a larger space. That means we want to give it much large as a long. So we are talking about constant here. Please understand, we are talking about constant. So whenever we are talking about a constant, we have to put a capital L or a small l at the end of the constant to make it like this. If this is 23 number, so you have to put a L to tell the compiler that this is a constant which is long. Integers, signed and unsigned. You know that integers are capable of handling negative as well as positive values, positive numbers, which are not decimals. So when we declare something as unsigned int num students, we know that number of students can never be negative. Can you assume that your students are minus 16? That is not possible. So unsigned, you are actually doing or shifting the range. That means this is 0, this is minus 32768, and here you have 32767, which is plus. So you don't want this area. So you are saying that I don't want signed value. So you are putting unsigned. So you are taking this range and adding it up here. So how much it becomes? 32767 or 32767 plus 327, this 8. Just add 32767 and 32768. You will get 65535. So this is the range you get from 0 to 65535. So you are just, if you declare an unsigned, you are increasing your range. So declaring an integer as unsigned will double the size of the largest possible otherwise. Unsigned, now when we do this on declaring the integer as unsigned, you are freeing the leftmost bit. We know that leftmost bit is what? It is the sign value. It gives you sign, but you know that the unsigned means this is always positive. So you are freeing up that value. You don't want anything to be, or one bit to be wasted for plus. Why? Because now the leftmost bit is free, and now it can be used to store the sign of the number. Okay. So note that this unsigned integer will still occupy 2 bytes only. Only the positive range has increased. So how to declare unsigned integer? Unsigned int I, unsigned I. This is to be seen. You don't need to put int. This is the shorthand form. Like the unsigned integer, you have short unsigned integer, you have long unsigned integer. So by default, this short integer is a signed short integer. If by default the long integer is signed long integer, if you want to make it unsigned, you have to specifically write this unsigned. You have to specifically give, otherwise it will be signed. Char, sign and unsigned. This character is taking 1 byte. Now this character is essentially an integer only. So parallel to the signed and unsigned integer, like the short and long, we can have unsigned and signed chars also. Char take 1 byte, but it can have different ranges. I'll tell you how. How to write a character or how to declare a character or define a character, char ch equal to a. So now this a is having a value which is 65, which is in binary. So this is all good. And if this 65 binary can be stored, you want to store minus 54 also. This can also be stored, and this is now a signed character. This is now a signed character. So a signed character simply means because a signed character is simply 1 byte, so it goes from 0 to 127, and here it goes from 0 to minus 128. So these are the highest and lowest limit. When you take an unsigned character, this side goes here, and now this is added. So this will be 127 plus 128. So you get 255. So the range is from 0 to 255. So let us see a program now. This ch character is till 291, or the value is 291. You want to print out the value of this 291 along with this character equivalent. We know that for ASCII, if we are dealing with ASCII, we have only value till 255, 0 to 255. 291 is above our range. So this program, what you are going to expect? Possibly 291 and the character which is related to 291, but this is not going to show. Why? Because the ch has been defined character, and the ranges are from minus 128 to 127, and 291 falls quite ahead of 127, which is not in the range. So ch will exceed the range. So whenever you exceed the range in any of the data type, if you exceed the range, when it surpasses the 127, it comes 128, then it will not give you error. But in fact, this 128 will go here. So minus 128 will be shown. Okay. Now, this 127, it goes from 0 to 127, then it comes back to 128. Then again 128, it will search for 128, and then you see that still it is not complete because 255. Now you see that this 291 minus 291 minus 255, or you say 256, say, because total number is 256. So this 11 minus 6 is 5, and this you have 8 minus 5 is 3. So you need to go ahead of 0 till 35. So that is how 35 will come up, and the character which is corresponding to this 35, which is the hash, will be shown. So in this program, you will see 35 and hash. Why? I just explained you. We have another program that would make the concept clear. See, you start with 0, you go up to 255, and you are adding it up, character ch plus plus. Now this is simply showing that from 0, this will show what? First of all, the number, so 0, corresponding character, then 1 corresponding character till 255. This is obvious from this program, all the characters will be shown. But again, this program will not show you this as expected. But in fact, this is an indefinite loop. Why? Because the character is assigned as simple character. It is not unsigned character. So the highest range is 127. And as we know, as we have just known, that when we go or when we surpass this 127, it will not go to 128 because 128 is not available. Rather, it will go to the other side, minus 128. It will go to that side, and now this again comes here till the time this ch plus plus is going on. But as it reaches 128, again 128 is not there. So it will go on, and this loop will be indefinite loop. I hope you got the idea, because it goes from 0 to minus 127 with this 0 to 127. Then it again go back to minus 128, means here. Then it again decrements because ch plus plus means it will increment the value. So here it will decrement the value. Plus means negative will, if you add 1, it will go here. So again it will come here, and this as you go ahead, it will go again and again. So this will actually dangle, or you can say the oscillate between these two values. So you'll not be able to see anything, right? So how to overcome this difficulty? we have unsigned character for this. The same program, if you write unsigned character and you just put this as 254, not 255, because once you, this is 0 to 255. The range is 0 to 255. That means if you are starting from the total value available to you is 256. So when you are starting with 0, you only go up to 255. So if you check 255, you are already ahead of 1. So 256 will be next value, and that is not acceptable. So you have to stop at 255. For that you have to just check for 254. You have to go up to 255. That is why we have changed this to be unsigned character. Now unsigned character is having a range from 0 to 255. You are trying to go up to 255 and putting the values and printing the values. Now everything will be fine. All the characters from 0 to 255 and the numbers will be shown. Floats and doubles. Float occupies 4 bytes. 4 bytes means 4 into 8. One byte contains 8 bit. So there will be 32 bit. So 2 to the power 32 is the range. You can say you just divide it into 2 parts, because again the float and double, they also take the negative value. So the range is this. And if you want higher value, double can be there. Double is taking 8 byte. So 8 byte means 8 into 8. So this will be 2 to the power 64 possibilities. Again, you divide into the range, negative and positive, these are the values. How to declare a double? Just place a double and put the variables here. Now if you want more than that, sometimes 8 byte is also not enough. For that we have long double. Long double takes 8 plus 2, that is 10 bytes. 10 bytes means 2 to the power 10 into 8, that is 2 to the power 80. This is the range, 0 to 280. This is for unsigned, and if you want the signed one, just divide it into half, take it here. So this is the negative and positive range for long double. So this is how this character int, float, doubles can be used. And now let us write a program to know what exactly is going on and how to print them. See, the format specifier, they are also different for all these. Take char C. When you want to print a character C, you want to enter the C and D first of all, C and D, and you want to print C and D, it will be printed. It will be simply %C because these are characters. %C. Now let us come to integer now. We'll go to float from here. Integer. You are scanning the value I and j. You are taking the value. But whenever you are taking the value of j, this is unsigned integer. So you have to take it in %u. Right? And whenever you are printing also j, you have to print it in %u. This is unsigned. Now let us come to this short one. Again, you are going to take k and l. So this k and l will be taken, but this l is unsigned short. So you have to take it in %u. The k will remain like %d. In long int, this to long int, again this long int has to be taken as this because this is long int. So it will be ld. And this is the unsigned long int. So it will be lu. ld and lu will take. When you come to double and float, long double, float we have already taken. Float has nothing to worry about because x will be taken in %f. We have known about that. When we are dealing with double, it will be lf. And when we have long double, we have capital L and F. This is small lf, this is capital L and F. Okay, so f remains small. So let me summarize what we have learned up till now. This signed character, unsigned character. Unsigned means there will be no negative, but the bytes will be same for the character type. You use %C only. In short, signed and unsigned, the range is for 2 byte is this, and there will be no negative for short unsigned integer, again 2 byte. But for unsigned, you have to take %u. When we come to signed and unsigned integer, again the things remain same here for 16-bit compiler. We are only talking about 16-bit compiler here, and you can just think about 32. It will just increase as I just suggested you. So this will be 2 byte. This will be %d and %u. Long signed, long int means ld you have to use, lu you have to use, and this will take 4 byte in 16-bit compiler. This is the range, and just add these two, you'll get this range. Now float, %f, double, small lf, long double, capital L and small f. This float 4 byte, double 8 byte, and long double 10 byte. There are things apart from this, that as we just saw that the size of the integer is compiler dependent, and this is true with character and float also. So it depends on the microprocessor for which the compiler targets its codes. The accuracy of floating point calculation may change. Just take an example of 22.0 by 7.0. So this will report more accurately by the VC++ compiler rather than the TC++ compiler. Why? Because TC++ is compiled for 16-bit 8086 or 8088 microprocessor. And this microprocessor, they do not offer any floating point support, but the TC++, they perform all floating point operation. They have a special software piece which is known as the floating point emulator. Floating point emulator. So this emulator has a limitation, and hence they produce some less accurate result. So this emulator becomes a part of exe. Then now when something becomes a part of exe, it will increase the size of exe. And if you have an increased size, there will be a performance penalty because bigger code will take more time to execute. So you see, if we look at the range of the character integer, and you see that there is a number extra in the negative side. How? See, if you take character, here you take 0 to 127, and here you have minus 128. So the one number is higher. Why? Because the negative numbers, they are stored not normally, but they are stored as 2's complement of its binary. So if you, let us see minus 128. So what is the binary of 128? Let us not take minus now. 128 is simply this one. Let us take the 1's complement, which is the simply making 1 to 0 and 0 to 1. So this will be the 1's complement. Now 1's complement is added. For 2's complement, 1's complement is added with 1. So we add 1 to this. We just add 1 to this. So the 2's complement will be this. So this gets stored. So a 2's complement is obtained by adding 1's complement to 1 complement. 1 complement is simply changing 0 to 1, 1 to 0. So minus 128, this gets stored. So this is a 8-bit number, and this can be easily accommodated because this is 8-bit number in character. But when you have plus 128, this cannot be stored in character because the binary equivalent of 127 will be, these are all 8 values, and then this is plus. So you have 0 here. So the leftmost 0 is a positive sign. So this becomes a 9-bit number. Therefore, the 1 plus 127 can be stored. Why? Because this is plus and 127 is simply like this. This can be stored in binary, and this turns out to be a 8-bit number. And what we have already seen in the program, what happens if you attempt to store 128. We know that 128 is not there, only 127 up till we go. So it takes the negative side, it goes to minus 128. And this is why, because from 9-bit binary of this plus 128, which is this one, only the rightmost 8 bits get stored. So when this part is stored, the leftmost bit is 1, and it is treated as a sign bit. So the value of the number becomes minus 128, since it is indeed the binary of minus 128, and this can be understood by the previous discussion. So you can verify that if you want to attempt 128, you will actually go to minus 127. 120, because 127 we have range, 128 you go to minus 128, and 129 you go to minus 127. So we exceed the range from positive side, we end up on the negative side. And this is true for negative side also. If we exceed the negative side, we go to the positive side. So this is the first part of the discussion on data type revisited. We'll be taking one more. Till then, thank you so much. Take care of yourself.